To start off, we're going to be looking at this first project. This is the Java 01 Working with Data project in the FRC 538 repo on GitHub. Now, if you're a member of the team, you'll be able to access this directly through your GitHub desktop. If you're not, you can still access it through that application. If you're familiar with using Git on the command line, you can pull it down that way. But we're going to, in these videos, assume you're using the GitHub desktop application, just in case. Otherwise, we're going to assume you already know what you're doing. And so all we're going to need from here is this URL, and we'll just copy that. So once we have that, we can close out the window. And I'm now in GitHub desktop, and I'm going to clone a repository from the internet. So you can pick github.com, GitHub Enterprise, or URL. Doesn't really matter which one you're using, but I'm just going to say, if we're looking at github.com and you try to copy and paste it, you're not going to find anything there. Same for if you go to URL, if you just copy and paste, you can find it there. So this is nice because it'll take the whole URL or just the username and repository. So if I copy and paste it here, it'll go there. And you can see exactly where on your computer it'll be. So I'm just going to let it go to that default location and click clone. And that's all we need to worry about right now. We now have a copy of that repository. So if I close that out, I can now open it up. And the way we're going to open it up is by going to Visual Studio Code, which I already have open on my Mac, but it's running. So the easiest way to do it on Mac or Windows will be to click the open. Now on Mac, open the folder and open the file, it work the same. If you're on Windows, you want to go to open folder. And this is kind of one of the first big steps in working in a repository, is making sure you open the folder at the right level. So if we recall, we know that the GitHub exported into our documents folder, and then we go to the GitHub folder, and then there we see it. And we could open it another level down, but we don't want to do that. We want to just select it and open it. And we'll get the warning from Visual Studio Code about trusting the authors. So we'll want to say, in this case, we do trust the authors. If we want to be able to execute the code, we have to do that. And to make sure you have the correct folder open in the process, you'll just want to make sure you can see the name java-01-working-with-data here at the top. If you're working on the left-hand side, it'll be over there by opening and closing your activity bar by clicking on the file icon. And you'll want to just make sure that you have these folders, the .gradle, the .vscode, app, Gradle, .get attributes, .get ignore, GradleW or GradleLoo, GradleLoo.bat, readme.md, settings.gradle. You might see other files as this repo evolves. This is kind of an early version of it, but if you see all this here, you're probably good. And then the last thing you want to do is go into the app folder, into the source folder, into the main folder, and you'll actually be going main Java data, and you'll just open this app.java file. And if you can see these buttons, this run and debug pop up, then you know that you've got your Visual Studio Code set up and all your extensions installed correctly, and your Java JDK installed. If you just click run right here, you should see a few things happen. You should see some stuff print in your terminal window down here, but you shouldn't expect to see a lot of things happening. If all that works and you don't get any messages, error messages coming back, then you're set up right. So once you're in this position, you're in a place where you can start following along and working in the repository and playing along with the tutorials. Before we get started learning how to program in Java, we're going to look at some of the basics of what you'll see in a Java program. The first thing you'll notice is the structure. You'll see that we're in this directory labeled src. We pronounce that source because it's where all of your source code lives. And there's a chain of folders here. So you have in the source folder, there's the main folder, then the Java folder, and then the data folder. And then in the data folder, we have a file here in this project called app.java. And what you'll also notice is at the top of the file is this line called package.data, or rather just package data. And if you notice, the name of the package matches this last folder here. So all of your source files are going to live inside this Java folder in one or more subfolders. And the package is going to tell you which folder you're in. So we know we're in the Java folder, obviously, because we're in a Java program, but we're also in the data folder when we look at this file. And if you look in the data folder is where we have the app.java file. So every Java file has this at the top. You may see just one word. You may see multiple words strung together with periods between them, where each word in between the periods is the name of a folder. So the deeper down in a folder structure you go, the more words you'll have. Here we just have the one because we are in the data folder, so we're in the data package. Then you'll also see that the entirety of the rest of the file is wrapped around by these squiggly braces. And we are inside something that is called a class. Don't worry too much about what classes are right now. We're going to cover that later. But one thing to notice is that the name of the class is app, and the name of the file is app.java. And so what you'll notice is that the name of the class is going to match exactly the name of the file before the .java extension. So we're in the data package. We are in the app class. And then we have this thing inside the class, another set of curly braces. And this is called, you'll most often hear it called either a function or a method. It goes by other names, but those are the two that we'll use the most here. And again, don't worry too much about what exactly a function or a method is. We're going to cover that later as well. Just know that this is a very special function called the main function, or called the main method. And we are going to be working in between these two curly braces. So all the code that we're going to write when we do these initial lessons are going to be inside of the main function, or inside of the main method. So there's a lot of ceremony, as we describe it in programming, around writing Java programs in this version of Java. In an upcoming release of Java, there may be some simplifications to this, but for right now, this is the structure that we're working in. So we have our Java file lives in a package. That package mirrors the folder. Inside of the Java file, you have a class whose name is the same as the file. And inside of the class, you have functions or methods, and the one very important function is called the main function. The main method is what actually allows your program to run, and so that's why any code you write either has to be in the main function or accessible to the main function in some way. And that later case is going to be more obvious much later. For now, we're going to focus on just writing code inside of the main function. So one thing you'll want to be careful of is making sure that your cursor is between this curly brace and this curly brace, and that you don't remove them, because if you remove the curly braces, you'll mess up the syntax of the function, which doesn't mean much. It just means that it won't run until you put them back. But that's kind of the overview of the structure of a Java program for what we're going to need to get started. And most of these topics we're going to touch on multiple times throughout the different lessons, and in some of them we're going to get much deeper involved. So with that, we're going to start moving into looking at how do you write the Java code that isn't just provided by the project. We'll start by seeing how to make the Java program actually do something. And what you want to look for is on the main method, you're looking for this run button. Now, if you don't see this, that could mean a few things. For one, it could mean that you don't have the Java extension pack installed. So you'll want to look for that and make sure that's installed. Otherwise, it could mean a couple of things. One, it could mean that you don't have the folder open correctly. So maybe you have just the file open and not the folder for the project. So in this case, it's the Java 01 working with data folder. So make sure you've got the right folder open in VS Code. If you've got the extension installed and you've got the folder open, it could mean you just need to totally close Visual Studio Code, make sure all instances are closed, and reopen it. You may need to restart your computer. There could be a few things there, but if you've got everything installed and open correctly, you're looking for this run button. So when you click, and you can click run here, you can click the play button up here, you can click open the run and debug tab and do run and debug here. So there's a lot of options for how you can run the program. I'm just going to click on this run here. And when you do that, it's going to open a terminal window and you're going to see a bunch of text. And all this is doing is just running the application. So all the way from this first / all the way down to the data.app is the command that Visual Studio Code issues to run your program. And then after that, nothing happens because this is a program that doesn't do anything. And so you're just going to see this blob of text that doesn't really mean anything to inexperienced programmers and really may not mean much to experienced programmers. So we're going to look at how to make the program actually do something. And so we're going to go into our main method. We're inside, in between these two curly braces. So we're in the app class, in the main method, and we're just on a new line. Now, you could delete all the empty text here and just be all the way up against it, but it's a better practice to kind of go with the automatic indentation here until you get used to that. Makes the code a little bit more readable, makes it a little bit more understandable as to what's where in the program. And so the first thing we're going to do is look at a certain command. And I'm going to type it out. It's system.out.println open parenthesis, close parenthesis, semicolon. This little chunk of text is the standard way to print something in Java. And when we say print, we mean make it readable to the person running the program. And system with a capital S dot out, all lowercase, dot println, all lowercase, is the name of a different function. So we said main is a very important method or a very important function. This system.out.println is a different function, a different method, and its primary purpose is to print a line of text. Now, if I hover over println, Visual Studio Code will use its IntelliSense extension to give me some information here. And the IntelliSense extension and the Java extensions all kind of work together here to give you this information. So this tells me exactly what println does, sometimes to a more technical level of detail than you might be familiar with. But as you read through it, you can kind of pick out the most important things. So, it terminates the current line by writing the line separator string. And all that's saying is that it's going to print a whole line and then go to a new line so that you can continue on. So this is a line of code, and because it's a line of code, it has to end with a semicolon. Now, not every line of code ends with a semicolon. Like up here, line 6 doesn't end with a semicolon. Line 7 doesn't end with a semicolon. Neither do lines 9 or 10. But you'll see line 4 does. And the lines that end with semicolons have a special name. They're called statements. And one thing you'll notice here on this line, I started this line with 2 forward slashes. That is also an important piece called a comment. And a comment is a line of text in your program that doesn't do anything. It doesn't run. It's just there for the human reader to see. So if you want to leave yourself a note or leave somebody else a note, one way to do it is to start with 2 forward slashes. So 2 forward slashes indicate the start of a one-line comment. And you can notice that it's a comment because of the way the text is formatted. So this text up here on lines 1 through 3 is what we call a multi-line comment. All right, and it's denoted by, you start with a forward slash and an asterisk, and you end it with an asterisk and a forward slash. So Java looks for any sequence that matches forward slash asterisk, something in between, asterisk forward slash, and that's how you create a multi-line comment. So again, if you've made the comment correctly, it'll have this kind of formatting in your VS Code, but we'll stick with one-line comments for now just until we get used to them. And so statements have to end with a semicolon. If I get rid of that, and I try to see my program, I get this little red squiggle. If I hover over it, it says syntax error, insert semicolon to complete block statements. The keywords here are syntax error. So syntax is referring to, does the program structurally make sense? It's kind of like writing a sentence in your native languages. If you're in English, right, you want to end your sentence with a period or an exclamation point or a question mark, something like that. The semicolon is doing that work for a statement. So things like here, line 8, that's not a statement, so it doesn't get a semicolon. Line 13, line 14, those are not statements. They don't get semicolons. Line 5, that's a statement. It gets a semicolon. Line 12, that's a statement. It gets a semicolon. So comparing what the program looks like now versus how it looked when I started, this is the only line of code that I've added. So if I were to just run this method again, notice I get more or less the same ceremonial text that runs my code. It still ends with that data.app and it ends with that data.app. It does a little bit more work here than it was doing, but more or less it looks about the same. But notice this time, before I get to my next line to start my next command, I get this blank line of text. And so this system.out.println is actually doing a little bit more work. It is going to print a blank line. Now it can do a lot more than that, but the way I've written it is exactly what it's going to do. So if you want to print a blank line, system.out.println will do that. If I want to print 3 blank lines, I can just copy that text and I can paste it and paste it again. I'm going to get rid of my extra tabs. And so this is going to print 3 blank lines. So when I run that, you can see there's my ceremonial, how do I run the program text? And then 1 blank line, 2 blank lines, 3 blank lines. So println can be used to print a blank line. There are other ways to print. There's a function called just print that's a little bit different from println. We're going to stick with println for right now because it's probably the simplest to understand and work with. And we're going to do more with it. But that is probably the simplest command, the simplest function we're going to use in Java to print something is println. And so far we've seen how you can use it to print a blank line. Now blank lines, while nice to have, are not the most useful thing to do in a program. And so we can actually put some data into our print line, our println, so we can see that on the screen. And so one type of data that you might want to print is some text. And in Java and in most programming language, we refer to just plain text as a string. Okay? And we can display that text by running a system.out.println. And inside these parentheses, we can pass what is called, you'll hear the term parameter and you'll hear the word argument tossed around for this. And they are just pieces of data that go into parentheses. And you might hear them interchangeably. They do mean different things. We're going to kind of gloss over the subtlety of the differences here. But you can pass arguments into the println function. And in Java, if we want to do a string, we denote that by starting and ending with quotes. you'll hear this called double quotes often. So if I were to just put these two double quotes into this println, and you notice I got println, parenthesis, double quote, parenthesis, semicolon. You should always see your double quotes in pairs. Otherwise, you have what's called a non-terminated string, which means the program won't be able to know where the string starts and where it stops. And you'll notice that Visual Studio Code gave us this little X here to tell us that we've done something. And so what you're seeing here is when the writers of Java developed the println function for you to use, they said that the parameter it's going to take is just named X. And so it's telling you, hey, the parameter named X is getting this value, and we are giving it the value here. So in this case, X is the parameter that the function expects, and then this string is the argument that we are passing in. And this actually has a special name. This just open and close string with nothing in it is called the empty string, because it is a string, but there's nothing in it. And if I run just this, you'll notice it doesn't look any different from just running println. And that's because println is effectively running with an empty string. And so if we want to put some text in here, all we have to do is put some other characters in between the opening and closing quotes. And the most common phrase that beginner programmers use is hello world. And so we're going to run with the hello world text here. And if I were to run this program with run, now hello world is showing on the screen where that blank line previously would have been. And you can put a lot of text in there. You can put in commas, and you can say, you know, my name is whatever your name is, and you can run that program, and it'll run that text, throw in an exclamation point, run that, you get the same thing. Now you might be wondering, okay, well, what about if I want to put quotes in the string? It doesn't seem to like that very much. Now, in some languages, you can do that pretty easily with just two double quotes. Java doesn't seem to like that. The way you can do that is putting a backslash before the double quote. And what this is telling Java is, hey, the next character, I want to be part of the string, even though it's a character you usually look for to end the string. So if I run that, you'll see that the quotes printed, but the backslash did not. And so what you'll see is that the backslash is called an escape character. And you can think about it saying, hey, escape whatever you were thinking you were going to do. This is just some plain old text. And so if you want to include a double quote in your string, you need a backslash quote. And if I run that again, you can see that we get the text as we would expect to see it. So that's how you can print some text. You can also add multiple lines. And with another println, you can say, you know, something like, I like to program. Because it's a new statement, it ends with a semicolon. If you run that, you can see, boom, there's the first line for that first println, and there's the second line for the second println. So that's kind of a little overview as to how you can display some text data, which again we're calling strings, in Java. And so that's kind of the first thing you want to play with. And so if you add some printlns, you can see how can you make text looks the way you want. There's a whole bunch of things you can do for special characters, new lines, tabs, special characters, all kinds of things you can print. So anything that's Unicode, Java can print. So in theory, if you have like emojis, Java should be able to print at least some emojis depending on what version of Unicode you have on your computer and things like that. So UTF rather than Unicode, I should say. Anything that is UTF, Java should be able to print. But again, it depends on what character set you have available and things like that. But So that's something to play around with before we move on. So spend some time practicing with that. Now there's actually another way to print text data that is not a string. And so if I were to run system.out.println with hello, this will print the word hello, no problem. If I hover over println, you can see, okay, println is taking in a string. And if we were to simplify it even more, maybe I just want to print one letter. Okay, I hover over, I get the same thing. I'm printing a string. So I'll just comment out that one line, I'll run it again, and it'll print just the H. And so whenever we are working with these double quotes, and that is this symbol, that's the behavior we get. But in Java, you can also do something a little bit different. And this is a very subtle difference between the two lines. You'll notice here I use double quotes, but on this line, I'm using what are called single quotes. And that's just the apostrophe. So in programming, we tend to call the apostrophe a single quote. But notice there's no red squiggle, so Java seems perfectly fine with that. But if I hover over println, no longer is it a string. Now it is a char or a char, which means it's a different type of data. A char, rather than being a piece of text, is just a single character, a single letter. In fact, char or char is short for character. So while in the string, I could type the whole word hello, right? In this method, I can't do that because my single quotes are saying, hey, it's a character, it's one letter, or one number, or one symbol, or one blank, or one, name it. That's what the single quotes mean. I'm trying to type a whole word. So it can only run if you've got one or fewer characters in there. So even if I run this, it's actually not going to do 0 characters because that's not a character. There has to be something in there. So if I run both of these, they both print H exactly the same. Now, why would you use a string or why would you use a char or a char? It depends on what you're working with. In this case, println is perfectly happy to take a string or a char. It doesn't matter to it. There are two different versions of println, one that takes strings and one that takes chars or chars. It doesn't really matter to that one. Now, it's not always going to be the case. Maybe you've got a method or a function that is only working for strings or is only working for chars. That's when it kind of matters. And so this is something that will take some getting used to, but that is the difference between the two. And one thing you'll find soon is that a char is not just for a single piece of text, a single character. Chars can be used like numbers sometimes. So keep that in the back of your head, is that it's okay to use a char as a number in some cases. Strings should only be used as text. That's kind of a general rule of thumb. Of course, the more specific you get, the more times you can find to bend or break that rule. But for now, just think of, if I want just text, I need to use a string. If I want just one letter, I probably need to use a char. But a char can also be used as a number, which we'll look at eventually, but not kind of in the immediate future. But those are two types of data that we use in Java. String to communicate text that is, 1, 0, 1, or more characters long, and a char, which is used as a piece of text in most cases, that only uses a single character. Now, it can be the letter H, it can be a letter, lowercase h, it could even be a number in quotes, single quotes. We get the number 2 here. If I print that, no problem, there's a 2 right there. Could also be a symbol like a $sign. Any character that can print can go there, just like those same symbols can go in a string. It's just that a string can have more than one, and a char is always exactly 1. But those are two ways you can print data. You can print string data, and you can print char or character data. And so that's something else to play with the print line function. In addition to printing text, you can also print numbers. So you will still use system.out.println, just like you would for the text, but you can just put in a number like 2. And if you run this program, you'll see the 2 printed out here. This is subtly different from a different line of text. You can print the character 2, or you can print the string 2. All 3 of these will look the same when you run the code, but all 3 are slightly different. These 2 lines are taking a text representation of the symbol 2 and putting that on the screen, whereas this line is taking a program representation of the number 2 and putting it on the screen. So while all 3 of these will behave the same way in terms of what you see on the screen, they are all doing something slightly different. And so this line is printing something called an int, which represents an integer type. And just like in math, in programming, integers represent the same kind of values. They can be positive, like 2, they can be 0, or they can even be negative. So all 3 of these will print integer values. And if you hover over, you'll see that println is taking in a type of int for the parameter there. For println on the second line, it's also an int. And on the third line, it is also an int. So in addition to strings, which are text in double quotes and up to multiple characters, chars, which are text in single quotes and exactly 1 character, you also have ints, which are integers that represent numerical values that are whole numbers, like -1, +1, 0, or numbers in that range. And just like the text values we've seen before, println handles them as well. If you've spent any time with numbers, though, you know that integers aren't the only kinds of number. And so while we have the ability to print numbers like 2, we may also be aware that 2 is also a representation of the number 2.0, which is where we start getting into our decimal numbers. So we have things like 2.0, we have things like 2.5, and so these start getting into another group of numbers. In Java, we say that the numbers that have a decimal in them by default are what we call doubles, and a double represents a real number. And so that's anything between -infinity and +infinity with any number of decimal places. Now, in programming, what you'll find is that we are limited to the numbers we can represent with doubles. So this is one of the limitations of computing with a traditional processor, is that, and system of memory, is that there are certain numbers you can't represent exactly in this way, and there are other ways to represent them. The doubles are just kind of the primitive data type to handle that. So a good example is you can represent the number 0.5 exactly very easily with a double, but you can't represent the number 0.1 with a double very easily. Again, there are other ways that you can exactly represent it, but they are a little bit more advanced data types. We're going to stick with the more simple double for now because it's what you're more likely to encounter when you're getting started. But any real number can be represented with a double. And so And that's within certain bounds. I believe a double can be anything between 10 to the 300th and 10 to the negative 300th, somewhere in that range. So very, very large and very, very small numbers, but not what we would say arbitrarily large and small. But here are some numbers you can print out, like 2.0, 2.5, negative 0.1, and this should illustrate some things pretty well, is that you'll see that it looks like it's printing them exactly, and it does a pretty good job of that. But as I hover over, you can see that we've got a double here, we've got a double here, and a double here. So in this case, this line to print the double 2.0 and this line to print the int 2 will print slightly different values. And so we'll just do those two lines. So we'll say print line 2 and print line 2.0. Now, mathematically, we know those are the same number. Programmatically, they are different numbers because one has the data type of int, so the Java virtual machine interprets it as an integer type, and 2.0 has the type of double, so the Java virtual machine will interpret that as a real number. And so because to Java they are different data types, they represent fundamentally different values. And that's why you get this difference when you print them out. And so that's another way you can represent numbers in Java that you might be familiar with in your everyday life. Now, we've talked about ints as a type of integer and doubles as a type of real. There's multiple integer types. Bytes, shorts, ints, longs are all different types of integer. It's just that the int type is kind of the most common fundamental type of integer you'll encounter. Same with real numbers. Doubles are the kind of standard that you'll encounter now, but there are others, like a float is another type of real number that you just don't see as often in modern computing systems. It used to be that floats were kind of the more standard. Now in Java and other languages tend to prefer double as the default now. But that kind of rounds out some of the basic types, both the text types and the number types. But there is one more type that you'll want to be familiar with before you kind of get going with others. So it's good to practice with these four, but there is one more. So far we've looked at text of multiple letters as a string, text of exactly one character as a char, integer numbers as ints, and real numbers as doubles. And so the last thing we want to look at is a very special type. And this type is special because it can only hold two different values. They can be true or they can be false. And when they print, you'll see exactly that, true and false. Now notice there's no double quotes or single quotes around these, so it's not text. It's a different type of number. And if you hover over println, you can see that that type is Boolean. And so Boolean is the last of the types we want to talk about right here. And a Boolean is simply a true-false value. The type is Boolean, and then the mathematical term is also Boolean, named after the mathematician Boole, B-O-O-L-E. And it is, again, kind of representative of a switch, on and off, 1 or 0, true or false. And so this is kind of the last data type that we're going to start with right here to cover out kind of your simple types and your text types, because these 5 together will be the ones, especially when you're first starting out, that you'll encounter most often. But just like the numbers, they print, just like text, they print. And again, notice these are not text values, these are Boolean values, because they are true and false. They are special symbols, special representations. And so with these 5 types, you can really start building out and working with data in a lot of ways. So this will kind of wrap up the ways that you can print data, at least with these initial types. and then we will start looking at some more things that you will be able to do with this data.